Let's go back the other way. Now, I've headed this integration involving inverse trig because we're not actually going to integrate the inverse trig functions themselves. We'll leave that for extension 2. So all we're really doing is going back onto what we just saw. So the standard integrals are this. If you see dx on the square root of a squared minus x squared, then that will give you the inverse sine of x on a. Or, of course, you now actually have a choice. Wow, how good's this? 2-for-1 deal. You can have either inverse sine of x on a or minus the inverse cos of x on a. And the other one for inverse tan. So if we see on a squared plus x squared, however, the difference is 1 on a. Because remember, when we differentiated, we ended up with a on the top of inverse tan. So dx on the square root of 4 minus x squared. What's a? Very good. Inverse sine x on 2 plus a constant. Notice, I only wrote one answer down. You could have, if you wished, have written minus the inverse cos of x on 2. Personally, I don't like negatives, so I didn't. Okay, square root of dx on 9 plus x squared. What's a? 3. So we get 1/3 the inverse tan of x on 3. Plus, of course, a constant. Ooh, definite integral. Are you sure?
Definitely.
Good. What's a? Inverse sine of x on root 2. Of course, you could have put minus the inverse cos of x on root 2 if you wish, but I didn't. And we're going between 0 and 1. You'll see these sort of numbers come up a lot because it means when we substitute in, we end up with exact values that we can work out. Inverse sine of 1 on root 2 is, of course, pi on 4. That is correct. Pi on 4. It is not 45. It's pi on 4. Because if you put in 45, you'll get the answer 45, which is a lot bigger than pi divided by 4. Pi divided by 4, in fact, would be less than 1. Ooh. Differentiate the inverse sine of e to the x and hence evaluate. Well, when I see a question like this, if I had to guess, I'd say that's the derivative. Because like hence, go back the other way. Let's see what happens. Differentiate inverse sine of e to the x. Oh, look, it is. Now, because I've done that one here, because I've just gone derivative over the square root of 1 minus the function squared. Therefore, when I integrate e to the x on the square root of 1 minus e to the 2x, I must get the inverse sine of e to the x. We're going from minus log 2 to 0. So inverse sine of e to the 0, but e to the 0 is, of course, 1. Inverse sine of 1 is pi on 2, minus the inverse sine of e to the minus log 2. But e's and logs cancel. But before I cancel, I've got to move the 1 inside the log. So that is actually log of 2 to the power of negative 1, or log of a half. So e to log cancels, and I'm left with a half. Inverse sine of a half, pi on 6. Pi on 2 minus pi on 6, pi on 3. Oh, that's not in the form a squared minus x squared. But I can make it in the form a squared minus x squared. I factorize. So I pull the 9 outside the square root sign, which also means the 4 becomes 4/9. But now the square root is in the form of a squared minus x squared. A is 2/3. So we get that 3, I've pulled out the front of the integral because we can factorize constants, we're allowed to do that. 1/3 the integral, and then inverse sine of x on a, so x on 2/3 is 3x on 2, plus, of course, a constant. There we go. 1e.